So, as we want to begin this class, I'm going to give you some examples right there on the screen. So, pause the video, try those examples, and then come up to see what you have gotten. The first example we gave you there is after half-lives, the fraction of the radioactive material that has decayed is dash. After 3 half-life, what fraction has decayed? So, we have 3 half-lives as a number of half-life 3. We're looking for the fraction that has decayed, and of course you know decay is what original minus remaining. Original minus what remains will give us decay. So let us first find what remains. What remains is actually original. It's 1 over 2 raised to power the number of half-life. So what remains here is the original 1 over 2 raised to power 3. So we have original 1 over 8 plus 1 over 2 raised to power 3 is 1 over 8. Now what fraction of the original remains? 1 over 8 remains. That's the fraction that remains. So if 1 over 8 remains, what's the fraction that has decay? Decay will be original. The fraction that the original fraction you have is 1, because 1 is a whole number. It tells you that is the original. It works everywhere. 1 is the original. Then in terms of fraction, then 1 over 8 is what remains from the question. So I'll subtract it. And now we have 7 over 8. The fraction of the original that has decayed is 7 over 8. Write down quickly. We're going to the next question that was given to you. Okay, question says the half-life of a radioactive element in 24 hours is 24 hours. So they've given you the half-life already. Half-life is 24 hours. Half-life is 24 hours. Calculate the fraction of the original atom element that would have disintegrated in 98 hours. So that's the time of decay is 96 hours. So they've given you the half-life, they give you the time of decay. They're asking you for the fraction that would have what? Disintegrated. Like we said, disintegrate simply means lost, or what you can find again. So we're looking for the fraction that has what? Disintegrated. That's decay. And decay is what? Original minus remaining. What is your remaining? Original 1 over 2 raised to power n. And we know there, since we are not given our number of half-life here, it is what? 1 over 2 raised to power time of decay over half-life. So original is remaining is original, that's 1 over 2 raised to power your time of decay 96 over half-life 24. And when you divide 96 by 24, you're going to have 4. 1 over 2 raised to power 4 gives me 1 over 16. This is the fraction of the original that remains. This is the fraction that remains. Now, the fraction that has disintegrated is what? Disintegrates. Like we said, 1, the whole number, tells you what everything is. Disintegrate is 1 minus 1 over 16. That gives us 15 over 16. That will tell us the fraction that has disintegrated. Now the next question says a radioactive isotope has a half-life of 8 days. What is the half-life? 8 days. 8 days is the half-life. So that one is already given. Question 6. Half-life, 8 days. What fraction of the atom will remain after 72 days? So a particular time of decay is what? 72 days. We're looking for the fraction that will remain. We're looking for remaining. Now, well, we could quickly just put your formula. Remaining is what? Original times 1 over 2 raised to power n. Do you have small n? No, but small n can also be what? Small t over big T. So we'll solve quickly like that. What remains is the original. You see, these cases now, they don't give you original, but they are simply asking for the fraction. Original, right? 1 over 2 raised to power t, which is 72 over 8. So the original is 1 over 2 raised to power 9. If you find the power of that, you have 1 over 512. That is the fraction of the original that does what? Remain as a fraction that remains. We've done so much about fraction related problems. Let's take the question now further to another level. Let's show you some jam specifics, because most jam questions will deal with what? Ratio. Most jam questions deal with ratio. Now look at it. It says two radioactive elements A and B has half-lives of 150 years respectively. Samples of A and B initially contains equal number of atoms. What is the ratio of the remaining atoms of A to that of B after 200 years? We're looking for the ratio of what remains from A to B. So since there are two problems, I like to put it in a tabular form. A there, B there. The two radioactive elements A and B has half-life 150 years. The half-life of A is 100 years. The half-life of B is 50 years. Right? Good. Samples of A and B initially contain equal number of atoms. So initially they have the same number. So I can say the original year is the same as the original year. They are the same as their original. Since no numerical value is given, use the letter that represents original. What is the ratio of the remaining atom of A to that of B after 200 years? 200 there is the time of decay. 200 is the time of decay. So after 200 years, what remains? What are we looking for? Remaining. What do? I take the value of what remains here, ratio, what remains on the other side, so that what's the formula for remaining? Remaining is original bracket 1 over 2 raised to power n, ratio, what remains here, original bracket 1 over 2 raised to power n. Good. So we're looking for what ratio of what remains here to that of B. So use the formula for what remains. Ratio the formula for what remains. NO is NO in our question. It's the same thing. But here we don't have number of half-life, so it implies what? Small t over big T ratio, small t over big T. In mathematics, whenever you are going to be dealing with ratio problems, they can divide themselves. They don't need to be down to divide up, no, they divide up to up. So this is gone. I have 1 over 2 raised to power. My small t here is the 200 over my half-life here is 100. Ratio 1 over 2 My time of decay there, small t is 200. My half-life here is 50. When I divide, I have 1 over 2 raised to power 2 ratio 1 over 2 raised to power 4. Of course, after dealing with this, you will have 1 over 4 ratio 1 over 16. Then, for this ratio sign simply means division. So I can change division to multiplication now. It becomes times 16 over 1. I can deal with it this way and it gives me 16 over 4, which is 4 over 1. That gives me 4 ratio 1 because 4 over 1 is 4 ratio 1. Or I take it from here, cross multiply 16 times 1, 16 ratio 4 times 1, 4. What can divide 16 and 4? 4 can divide 4 divide 16, 4. 4 divide 4, 1. So that's the ratio of the remaining atoms of A to that of B. Now the next question says, what the percentage of the original nuclei of a sample of a radioactive substance left after 5 half-lives is dash. So they simply say after 5 half-lives, what is the percentage that is left? First of all, we need to find the fraction that is left. Then we have original half-life. Sorry, half-life is not given, but then they're asking us number of half-life is 5. After one half-life, it's actually 1 over 2 raised to power 1 that remains. When they say after 5 half-life, it's 1 over 2 raised to power 5. So that gives us 1 over 32. This is the fraction that remains. Then if that is the fraction that remains, the percentage of it is going to be 1 over 32 times 100%. Once you do that, 1 times 100 is 100, 32 times 1 is 32. You're going to have what? Approximately 3%. That's the percentage of the original nuclei of the sample that is left. I believe you are following in the question.